In this experiment, I'm going to show you how concentration affects rate of reaction. For this, you'll need a conical flask, a bung with a delivery tube, a trough full of water and a measuring cylinder, about 100 ml. Make sure the delivery tube is going into the measuring cylinder and that the measuring cylinder is full of water. You will then need a set of scales and some marble chips. Because we're looking at concentration, the temperature needs to be kept the same and the size of the marble chips need to be kept the same, so I'm going to be using medium all the way throughout this. The first thing you need to do is weigh out approximately 5 grams of your marble chips. The closer you get to this, the more accurate your results are. The second thing, you will need a range of different concentrations. So here I've gone with 0.2, 0.4, 0.6, 0.8 and 1 moles per decimeter cubed concentrations. Start by measuring out 50 ml of your first concentration, in this case 0.2 molar. .4 molar. .8 molar. .1 molar.
So if we have a look at the results, you can see that as the concentration increases, so does the volume produced in 30 seconds. And that volume is of carbon dioxide gas. So if we put that onto a graph, you'll be able to see in a much clearer term. So the concentration 0.2, we produced 6 ml of gas. So we put that on there. For 0.4 we produced 9. For 0.6 we produced 22. For 0.8 we produced 60. And for 1 molar we produced 112. So you can see, as the concentration goes up, the volume of gas produced also goes up. So, when we talk about concentration, we talk about the number of acid particles in a certain volume. So if we imagine this tray as the volume of liquid, so 50 ml, and we imagine the dice in the middle as the marble chips, and the marbles here as the acid particles. In a low concentration, there are very few particles. There are few particles, there won't be as many collisions per second with the marble chip. So you can see moving around, occasionally they'll react. To increase the concentration, you need to have more acid particles. The more acid particles there are, the more collisions per second. The more collisions per second, the more reactions happening. The more reactions, the faster the speed of the reaction. So if we have a look at this, this has got a low concentration. So we've only got a few of the reactant 1. 30 in particular. So when I start the reaction, the particles are moving around, and when they collide, provided the collision is successful with enough energy, a reaction occurs and we produce our products. So the time taken for those reactions to occur should increase with the more particles that you put in. So it took 16.9 seconds to react to produce 20 of your product. If I were to increase the concentration to medium concentration, you can see straight away there are more particles in there. So if I start the simulation again, the more particles there are, the more collisions there are per second. The more collisions per second, the quicker it should reach 20 products. Which, as you can see, was 9.16 seconds, much quicker. And finally, if we have a look at high concentration, we've got more particles again, we're up to 60 of reactant 1. We start the simulation. And it took 3.7 seconds for 20 products to be formed.